Yes. Good morning, everyone. Yes, Dhaval sir, are you there?
Yes, I'm there.
Yeah. Thank you, sir. Yeah. We'll start the meeting within couple of minutes, sir.
Yeah, it's okay.
Yes.
Good morning. Hello.
Yes, sir. Yes, Dhanraj, sir. Yes, sir.
How are you, sir?
That's fine. Fine. How are you?
Fine, sir. It's like long time to
No.
have interaction with you since Shiga. Hello, Paltarkar ma'am.
Yes, sir.
Uh, shall we start?
Yeah. Yes. Good morning, everyone. Respected dignitaries, esteemed faculty members, distinguished speaker, and dear participants. Today, on behalf of Dr. D.Y. Patil Unitech Society, Dr. D.Y. Patil Institute of Technology, Department of Computer Engineering, I welcome you all. I, Mrs. Vasudha Paltankar, along with my colleagues, Dr. Dhanraj Dhotre sir, Mrs. Bhati Sahu ma'am, welcome you all on the third day of 1 week faculty development program on AI/ML in healthcare and medical informatics. It gives me great pleasure to introduce our distinguished speaker for today's session. Please join me in welcoming Dr. Dhaval Maheta, Professor, Veer Narmada, South Gujarat University, Surat. He has 22 years of postgraduate teaching experience. Dr. Dhaval Maheta specializes in teaching quantitative methods, financial management, production management, research methodology, and financial derivatives. Sir has presented and published over 40 research papers in national and the international conferences. Published books on Minitab software, statistical analysis using R software, machine learning using R Rattle, data analytics using R. I would like to request Dr. Dhaval Maheta, sir, uh, to please proceed. Over to you,
Yeah.
sir. Thank you.
Yeah, fine. Okay, sharing a screen with all of you.
Yes, sir. Please share.
Yeah, yes, sir.
Yes, visible, sir.
How many participants are there?
126 now.
126. Oh, it's a big number.
Sir, actually, it is like 285.
Uh-huh.
So people may join like within 2-3 minutes.
It's a big number.
So like the expert like you are there in the FDP, sir. So people are eager to listen you. That's why that's why it's a big number.
Okay.
And I know, like since many years, I've been in touch with you, so I know your expertise and all.
Okay, thank you. Yeah.
People are also aware about your expertise. They wanted to listen you. They wanted to learn from you.
Okay. So can they unmute themselves? Is it possible that if I ask questions, they will be unmute? They will.
Yes, yes, sir. Yes, sir. Yes, sir. They can
Oh,
unmute.
fine,
Even
fine.
they can start video as well if it is required.
Okay. So let's start the session. The session is all about natural language processing. Okay, and so it's a field where it's a field basically where the intersection of computer science, English, that is linguistics, and artificial intelligence comes into the picture. NLP is used in different domains, like let's say for the media, but specifically today we are going to talk about health sciences and how is it useful for us. So you are all aware about Google Translate, Siri, or even the autocorrect on the phone. When you type a message in Gmail, it gives you the suggestion, the next suggestion, right? So just write down. Are you aware about that? When you write something in the Gmail, it gives a suggestion that what could be the next word. Even in the Google, it gives the suggestion that what could be the next word. So believe me, all these are working under the NLP. Now, why is it necessary that NLP should be introduced in healthcare? See, doctors basically are spending 40% of their time. You can see at the bottom, 40% of their time just writing and reading the clinical notes. Okay. Now, in this, what we want is we want to extract the key information that what is the type of the disease in this particular disease, what is a prescribed medicine, what is a follow-up required. All this we want something on the system. Okay. So if a particular disease is detected, then all the remaining processes should be done by the system. We want that thing. So which are the areas in which NLP can be used? So extracting drug interactions from the clinical notes, we can predict the disease. Recently, I came across one of the very interesting thing that one of the doctor told me that after a few years, the blood report will also be having the probabilities of the disease which you are going to have within next 5, 10, and 15 years, the probability of the disease. I hope I am audible. Okay, I hope I am audible.
Yes, sir,
Yes, sir, you are.
Okay, so see what the doctor told me that, just a minute. Okay, so what the doctor told me that within a couple of years you'll be having another report which will be talking about the probabilities of you getting a particular disease. Now the information which is available with the doctors, just imagine this information is available in the form of clinical notes 1. There is a blood report 2. There are some scans, CT scans, MRIs, and we have to create a brain from all this, which is you can say very difficult. But NLP has got some answers for us. So we start with the first one, where NLP can, just a minute, let me change the slide. Can you see here, all of you?
Yes, sir.
So the first
Yes, sir.
thing, the first is NLP is going to transform the healthcare in 4 ways. First is clinical decision support system. In this, we are having 2. It automates the risk identification and alerts for the drug interaction. We should be very thankful to our government. Okay, I'm just talking about the government. Okay, that at least some efforts have been initiated to create the health records. This health records, after 4 or 5 years, will start doing miracles. Believe me, it will start doing miracles, because once a database has been built. Because, so let's say that you have met with an accident. and you have been admitted in the place where nobody is aware about your complications, about your comorbidities, all these things are, they are not aware. But if the health record is with them, so this medicine should be given or should not be administered. Everything will be on the digital platform, which is really good. So at least we have moved one step ahead. Now, another example is the adult person enters the emergency room with fatigue and breathlessness. So the system will scan the history, make the clinical notes, the lab reports, the previous admissions, and flags that what can be the high risk of the heart failure. The probabilities will be there, and now based on this, what are the medicines which could be given? Is it useful? Yes, it's useful. Now, what is the position of doctors here? See, the question will arise that will this NLP replace the doctors? I will say no, it will not replace the doctor, but it will be just like a second opinion on our system, very powerful second opinion on the system. And therefore, the chances of getting wrong will become lesser and lesser. To your surprise, the Mount Sinai, okay, I'm repeating, Mount Sinai Hospital in New York are actively identifying drug-to-drug interaction. And as soon as a conflicting medication is entered, the system will alert that this is a conflicting medicine and probably this can create a problem in the patient. Right? So this prevents the errors while administrating the medicine. Is it clear? Any questions up till now? I'm going very slow to make you understand how. Then I will come to the method, how NLP is working at present. I'm just trying to explain you the importance, how it will work. And what is the science behind it, that also I will explain. Right? And if the time permits, I will show you a little bit of the coding. Shall I proceed? All of you are with me? Right? Say yes. Say right. Small y in the chat box to increase your attention span. Just small y. Are you all listening? Small y is necessary. Okay. Increase your attention span. Right. Now let's proceed further. It will accelerate the research by identifying the cohort. Can anybody give me the example? What do I mean by this? Anybody? Research acceleration will be, the research will be accelerated by identifying the cohort. What does it mean? Just anybody. Anybody. Okay. No answer? Anybody can give this answer? Right. Now let's understand this concept. Doctors or the medical sciences require some patients for the trials, clinical trials. And we want to identify, we want to do the sampling. The sampling is based on some inclusion criteria and some exclusion criteria. I am carrying out a research on the vaccination. Let's say the COVID-19 vaccination. And I'm looking for a particular type of a patient's combination, that this patient's, this age group with this comorbidities, what are the factors, what are the probabilities? This will create a sampling for us based on inclusion and exclusion criteria. Is it clear? I hope things are getting clear. Shall I repeat this part, or you understand this? This NLP will create the sample based on some conditions which we specify, that I'm looking for a clinical trial for the patients having this particular combination, this age group, this gender, this locality, and this comorbidities. So it's really good for us, right? It also works at the population health level. Now, there is one video on YouTube where you will find that there is one particular area where Coca-Cola, okay, I'm not, let's say that there is one drink, not say anything. There is one drink It has been used extensively. Okay, there is one drink which is used extensively, the carbonated drink which is used extensively in that particular area, and we want to see the health repercussions on it. That what has happened. NLP can process thousands of clinical records, identify the patterns like why the blood sugars are rising, okay, why there is a trend in specific age group, why some geographical areas are getting the cancer, right? Anybody aware about the cancer train? Anybody aware about the cancer train which runs in Punjab?
Yes, sir. Yes.
Right. Now, who identified the pattern in this? That there is some pattern which is there, and therefore it's a necessary that some action should be there. A simple ticket issuer found the pattern, that there is a pattern, that why there are so many cancer patients moving from this to this, and why there are so many people availing the cancer relaxation in the train. So here anybody can identify the pattern, and therefore it's necessary that what is going wrong in the system has to be identified. Is it clear? Okay. Anything you tell me which is making you curious at this moment of time, and it's necessary that NLP will solve it. It's no longer that only the are quantitative variables are only inducing some disease. These days, qualitative variables are also have came into the picture. For example, few years back, the heart the heart problem was purely related to the quantitatives like age, cholesterol, okay, obesity, blood pressure. Right now, these days the focus have started shifting. We have now moved toward the qualitative variables: stress, work-life balance. Now here it is necessary that NLP comes into the picture. As far as the things which we were able to measure it, quantify it, things were fine, regression analysis was done, that is all over. Now a time has come that we start talking about more nuances, that what are the factors which contribute the heart disease. Anybody who feels that, sir, this is my curiosity, can NLP solve it or not? Think and tell me. Yeah, can I use NLP to identify stress, anxiety, and depression in diabetic people after giving audio simulation? Yes, you will be able to do it. You will be able to do it. But for that, you will have to learn some of the transformers which I'm going to discuss. You will have to do the coding in Python, and there are some transformations like bird transformers and clinical transformers which we will have to deploy. You will be able to do it. Upload all the notes, and you will be able to identify. Right? Anybody who is curious, that sir, I want to find out using NLP some patterns. Tell me, anybody. Just be curious. Any qualitative insight which you feel that this is a thing which I want to find it out. What is a relationship which is existing or not? Come on, tell me.
Hello.
Yeah.
So,
हाँ सर,
हाँ बताइए.
please go ahead, madam. Please go ahead.
so there is a one question in the chat box. Can I use NLP to identify the stress, anxiety, and depressions in
I
diabetic peoples after giving the audio simulation?
see. Giving audio, I already answered this thing. We require some notes. Hmm? And in diabetic people, how will we do it? First of all, we'll have to record their experiences. And once the experiences are recorded, there is something like an inclusion and exclusion criteria that specific age group people having a diabetes, and what type of stress, what type of anxiety. So basically, this is a qualitative interview which we'll be administrating. Now, what is this audio stimulation? Can Swati, can you elaborate? What do you mean by audio stimulation?
Yes, sir. Actually, I'm going to give the enchanting meditation, or I can recommend some music. After listening that, we are going to capture the EEG. What is the changes in EEG before stress anxiety and after stress anxiety?
Very nice.
Uh,
But
actually, just
how will are you using any scale or any meter to measure stress, anxiety, and depression?
actually there are some questionnaire. Actually, this is my PhD topic. Just I'm going through that. Just this year I have registered for PhD,
Hmm.
and I just taken some predefined questionnaires like DAS questionnaire is there, big anxiety depression questionnaires are there. So based on
Uh,
that, I'm going to take the real time data as well as the database which is available to the doctors.
Very nice, fine. See, there are ways in which there are some machines available for measuring the stress, anxiety, and this is also experimental research which I have seen in some universities. So either you go with NLP or the experimental research, both are advisable. You can do it, no problem. But whenever you start, record their strengths, anxiety, and depression before starting the audio and after starting the audio, right? Record that way.
Yes, yes, yes. But just I want to ask you, either by using NLP, we are going to pre-process that EEG signals, like all the basic operations we are going to do on the EEG signal or any other image signal. Is it possible by using NLP?
No, that's what I'm saying you that if you are capturing the signals, NLP does not come into the picture. NLP is pure. What are the you can say experiential research जो होता है ना कि what
Okay,
are their experiences which are
oh,
being recorded. No
okay,
ESG signal, nothing. This is not about signal processing.
okay, okay, right, right, right.
Got it? So
Yes, yes, yes. Yeah,
let's
yeah.
proceed further.
Thank you, sir.
Now it can be also used in automated coding and billing. How that how many times this particular patient's this code was generated and on that basis what was the emergency and what should be the bill, right? Moreover, whenever a particular code is generated, so it reduces the manual error of accounting also, right? And it improves our revenue cycle by it says that it improves the revenue cycle by 15%. Let's proceed further. Now, what is this whole science? Our function is text classification, basically categorizing the text. You are aware about the example of spam, not spam, sentiment analysis. This all comes in text classification, which we have to do it here. There is no way. We have to classify the text. Then comes the next part is named entity recognition. Identify the name of the people, place, disease, drugs in a particular text. After this is being done, we use POS, part of the speech tagging, where we identify nouns, verbs, adjectives, all in this particular speech. Then we start doing translations. Okay. After this is being done, speech recognition, text summarization, creating the text board, and then the last part is text generation. That I give a particular disease and it starts generating the sentences. It's just like we want to create our own chat GPT. Use case. So electronic health records, EHR, it extracts key details like diagnosis and medicines. In clinical decision support, how NLP helps to read the notes and suggest the next steps. In medical coding, assigns the diagnostic codes from the discharge notes. Chatbots for patients provides 24 by 7 health advice using conversational AI. Disease surveillance, analyzing news or clinical test for outbreak detection. Clear? Shall we proceed further? Is it clear? Right. But there is a problem. On right hand side, can you see the image? Can you see the problem? What is the problem? Big problem we are having. It's not so easy as we think. Why? Why? It's not so easy as we think. What's the problem here? Can you tell me? What's the problem which we are facing? So the first challenge is the complexity. The first is a volume of the data, Sriya, is coming on later on. First is complexity. You can say medical terminology, you can say jargon, you can give any name, right? But the medical language is not like an everyday English. It's very specialized, extremely often it is ambiguous. And how the dosages are written, how the medications are recommended, it's very difficult for even the humans to understand, and we want that the machine should process it and build up the artificial intelligence, which is very difficult. Now I'll take one example to understand. Okay, you must have seen the doctor notes that also are not clear, and from that we want to make the artificial intelligence. Now, I'll give you a very simple example. Is it easy for the person to understand, a normal person, that a patient complains the shortness of breath for 2 days, rule out pulmonary exovolism and all that such words have been used, and this is not a normal English. Now we have to process it, is very complex thing, and therefore it is very difficult to develop something from the very complex thing. Variability. Do you think that the doctors are using the universal grammar? No, every doctor is having a different terminology, and there is non-standardization, and therefore it is very difficult to process also. One of the interesting thing which we always I see in the blood reports, that if they want to say that this disease is not found, no evidence of parasites were found. How they write? Do you remember? Can you recall how they write? No evidence of this thing was found. So they start with the negation, and uh, to process such type of information is also very difficult. Clear? Is it clear? Any questions up till now? No? Right. Now, some doctors are using the cryptic notes, like if I say HTN, so it is a hypertension. If high BP, it's a high blood pressure. A fracture may be written, just a fracture, they write FX. So there is no standard way of writing, and it is very difficult to decipher this in our systems. Somebody had rightly said volume. See, if you are having a structured data which is in Excel or CSV format, believe me, to store it is very, very easy. Thousands of records can be stored in Excel and CSV file very easy. But now you are having images, you are having scanned notes. It will take too much time, and storing is not is also not a problem, but processing this information is also a big problem, because this uses a large volume of data, right? So the third challenge is of the volume. A single patient can produce multiple records, and in one hospital there will be hundreds of patients which are generating thousands of records. So it's very, very difficult. So we are in the problem of complexity, variability, and volume, right? Shall I proceed further? Okay, next. Now comes medical jargon and abbreviations. See the first one, terms like malignant neoplasm instead of cancerous growth. They're using jargons, and this is also difficult. SOB, right? See the second example. SOB means the shortness of breath. or it can be sitting out of the bed. One is a good sign, another is a bad sign. Another will have a red flag. So one will have a red flag and another one will have a green flag. The codes will change, and therefore the training the model which we have created may sometimes fail. The question is, can we not detect it, that what has gone wrong in the system? Now just imagine you have processed multiple records, and in your training data set something went wrong inside, and just imagine what can happen. It can give you a wrong codes. So this is a second challenge. Okay, shall I proceed? Shall I proceed? Now,
Yes, sir.
Sir, yes.
now there is a unstructured data. 80% of the medical records are completely unstructured. There are some countries in which everything they want it into the structured format so that the things can be processed. One of the app which is available is a YOLO app, okay, which can do this processing. But at present in India, all these things are completely unprocessed.
Sir, you are not audible.
Okay, so there is a synonym and even there is a polysemy. Now, what does that mean? That 2 lakh medical observations are there. Not observations, abbreviations are there. And the same abbreviations can mean completely different things in different context. What is the word I have used? What is the word I have used? Now the time has come that I introduce the concept of context. That this particular abbreviation has been used in which context. So when there is a context, there is a relationship. Clear? That this particular word, now satisfaction related to what? Satisfaction related to the hospitality in the hotel, satisfaction related to the services in the hospital. So we want to see the background, that in which background this particular word has been used. So we also have to extract the relationship. Okay, next challenge which we are facing is unstructured data from format. Clinical notes are there, free text narratives are there, dictations are there, often shorthands are there, idiosyncrasies are there, lack of standardization, no uniform structures, and semantic ambiguity. So negations are the basic problem. I also give you the example of negations, right? What are the negations? Just try to recall what do you mean by negations. What is negations? The
Doctor write in the report that no parasite.
No parasites have been found, right? No parasites have been found. Now let's proceed further. Now examples of healthcare data sources. We are having 1K plus EHR pages in a single hospital. 5 major categories are to be considered. Clinical notes types are to be considered, and this we want to process it. Of course, the potential is very, very large. We can definitely get the advances in precision medicine, better patient outcomes, and LLP market will grow 25% annually. This is a very rough estimate which has been given by 2030. The packages are being made like SPACY, SPA, CY, SPACY in Python. But or still we are having this problem that we don't have any universal NLP system. I'm talking about universal NLP system. Just understand, one we are running on localized, that is for our hospital, and one is the universal NLP system by the government. That is not there. Eventually, let's see, things will be better. Now we start with the first one. Is it visible, all of you? Is it visible?
Yes.
Okay. What is the first thing which in any NLP which we have to do is we have to remove the noise, eliminating irrelevant elements for clear analysis. Remove noise is having a different meaning everywhere. Please listen carefully. Don't think that it is only a textual context. No. If if your data is image, the CT scan, the noise is different. If it is a handwritten note, the noise is different. If it is a Word file, the noise is different. And if it is an Excel file, the noise is different. Can anybody elaborate why I'm saying that these noises are different? Anybody? Come on, tell me.
Hello.
Yeah, please tell me.
Sir. In this case, noise is different because it's not in a structured way. Whatever data is there, even in the structured data, noise is having some pattern.
No,
You can have some.
noise does not, we don't talk about the pattern here. Noise does not have the pattern. Noise, if you remove the noise, then the pattern becomes clear.
True.
So what are the types of noises? Let's start with the clinical notes. What can be the noises in the clinical notes which have been written?
Say, short forms are there.
No,
Indication.
no, that we can take care in the processing. That is a stop words.
Right.
What are the noises in clinical notes?
Ambiguous notations or ambiguous uh, text material, text words.
So in different cases, I think that the noises would be different in the sense when we are saying stop word removal, anything that is a stop word has to be removed, right? So in
No,
this case,
ma'am, stop word is a different operation. See, it is at the fourth stage.
right, sir?
I am just talking about removing the noise in 4 different types of data. So in the clinical notes, the first noise, I'm just talking about the clinical note, the prescription which is written by the doctor. I have to remove the signature of the doctor, 1, the
All right.
stamp of the doctor, 2, the letter 3. Okay.
Yeah.
So this is a noise in a clinical notes. Okay.
Yeah.
Now you tell me what can be the noise in the image file?
Any text probably.
Right. So there are some text which are written in the images.
Yeah, would be treated as noise because that is irrelevant while we are processing an image.
That is irrelevant to us. Anything else which we have to remove it?
Some symbols are there in images, for example, X-ray or say CT or like that. So patients, sex is there, patients, maybe sometimes some little bit address is there.
Okay,
name
so
is there.
yeah. So there can be some blurriness, or there can be something which we want to remove it. And what is, we always say that in image file we have to concentrate on some area. And what is that area known as? What do we say that area is?
Region of interest.
Huh?
Area of interest. Area of interest.
Area of interest, right? We say this as an area of interest, that this is our area of interest in which we will be working, and it has to be focused. What can be the noise in the Excel file?
Maybe outliers in the Excel sheet.
Perfect. Outliers are noise. Outliers. some missing values are there, some extreme values are there, which we have not considered or which should not be considered. Otherwise, our things can go wrong. Now we have the next stage in text pre-processing is the case conversion. We want everything to be standardized. Everything should be brought in some at same level. So we will convert all the cases into lower cases, right? Next is punctuation removal. All special characters are removed. Okay. Shall I proceed? Comma, spaces, everything has to be removed. And next is a stop words removal. Stop words removal does say we don't count that how many times A has appeared in the document or N has appeared, the has appeared, and these are to be removed. So I have given you the example, the quick brown fox jumped over the lazy dog becomes quick brown fox jumped lazy dog. Everything else is removed. Clear? Now comes the tokenization. Okay, what is your thinking about the tokenization? Tell me. And which are the libraries which you are using for tokenization? Tell me. I will recommend some libraries from my side. The easy libraries. What is a tokenization? Come on, tell me. What do you mean by tokenization?
Dividing the words
Dividing the
words into the small partitions.
then in tokenization we are having unigram, bigram, and trigram. Okay. Now, why this concept is necessary? That tokenization says, right, breaking the text into discrete units and discrete sensible units. Chest pain. Okay. So only the chest does not have any logic. We want that these two things should go together. Chest pain. So when there are two words which should go together, this is known as a bigram. What it is known as? It is known as a bigram. Now we want that three words should go together. Elevated blood pressure, three words. So this is trigram. So tokenization has to be done because after doing the tokenization, we will be able to develop a relationship. So first is tokenization. Now, can you tell me which are the libraries which are there in R for tokenization? Which are the libraries which do very well tokenization?
I can tell about Python.
Which are the libraries?
For Python, it is NLTK.
Very nice. For Python, very nice. It is NLTK. Then
Spacey, Bird,
Spacey, then
Bird.
Bird transformer is there.
Yeah.
Bird, BERT, Bird is there.
Byte pair encoding.
Sorry.
This is also.
So please write down the library. I am putting in the textbook. Quanteda, text mining, TM. And there is one more. When I will run the R, I will show you that. So these are the libraries which will do a very nice tokenizations for you. Please write it down. Please write it down. This will do very nice tokenization for you. Okay, stop words removal is to be done. Next is stemming. Now this stemming, any example on stemming? Anybody can give any example on stemming? Stemming. What do I mean by stemming? Why is it necessary?
Probably all the root word has to be considered, like study, studying, studies should be converted into study. So the root meaning is study. So anything related to studying should be
very
cropped
nice.
to studying.
So it should be brought to the root word so that the standardization is achieved. See, basically we are doing all these efforts to do for the standardization. So that it is very easy for the NLP for us to create any model. Next is lemmatization. Stemming, sometimes we may get good result and sometimes it is very adverse. Be very careful in it, because stemming, I have seen the cases in which the stemming has gone just what was the example, that treated, let's say treated, so it has gone to the level that there can be a one word more. Let's take one example, and that is, we were interested in mm, just a minute, we were interested in dichotomous. Okay, let's say dichotomous. It went on doing the stemming and it reached to the level dic, so that is dictionary. Okay, it went to the stemming to that level. So be very careful in how much stemming is to be applied. Next is lemmatization. What is lemmatization? What is lemmatization?
The process of grouping like
No,
different
no,
inflected form of word, like they say run, ran. We can take
no.
example.
Now the grouping matlab, we want, it's basically you are identifying a synonyms, and
Okay.
we want to keep it in the same, we want to keep it in
No,
this
different inflected form of word.
different inflected form of the words. We want to keep it
Yes.
in one bag. What is that bag known as? After doing all this, we want everything to be, we want to put it in the bag.
Lemma.
It's a lemma, right? It's a
Yeah.
lemma. And we want, after that, where we want to keep all these things. We want to put it in the
Dictionary?
bag
Dictionary?
of, we want to put it in the bag of words.
Big of
Okay. What this bag of words, it is coming. Any, up till now, any question is there, please ask. Up till now, any question is there, please ask. Okay. So let's proceed further. Tokenization. I have given you one example. So it's basically a process of dividing a text into separate word or phrases. Before 4 or 5 years, just the we were doing tokenizations to create the graphs, but now we are doing tokenization for developing the relationship. So here I will have to identify which is a proper noun, verb, determiner, noun, and after this a relationship will be developed. Okay. Next is a tagging. So a raw text is there. We tokenize it, text cleaning, POS tagging is being done. What is tagging? See, this is a tagging. This is what we are doing. This is tagging. This is a conjunction. This is noun. So after the tagging is being completed, the next process is named entity recognition, person, location, and organization. Specie library is famous for achieving 90% F score. Okay, it can achieve 90%. So how our model is successful, that we measure with the help of F1 score. So it's successful 90% times. Now the POS tagging, in this, three things are to be done: identify the grammatical rules, create the statistical models, and then you go for the rule-based approach. So once the tagging has been done, after this, we start building up the model, and then we go for the rule-based approach. Anybody can give me the example of what is a rule-based approach? Come on, tell me. Rule-based approach. Anybody can give the example of rule-based approach? We want to create the rule after making the model. What is a rule-based approach?
in which we are applying the linguistic rules, and after
What?
that we are
Yeah.
processing the
What type of rules? Any one example.
Okay. There are various steps like domain-specific linguistic rules, such as grammar rule, syntax patterns,
Very
semantic
nice.
rules.
Very nice. So that's coming for us. C is right. C is right. So in named entity recognition, we locate and classify entity types. Diverse approaches are being used as is rule-based approach, machine learning, and hybrid methods. So we input the text, pre-process it, POS tagging is being done, and named entity recognition is being done. Next is we create the bag of words. First, see what is a bag of words. See, this is a bag of words. The word and document one. In document one, is it appearing or not? So basically, it is a binary 1 and 0. Document 2, binary. Now, why we do this? Why we create the bag of words? Why we create bag of words, and what is the concept of bag of words? And what is the disadvantage of bag of words? What is the disadvantage of bag of words?
Advantages could be increase the performance of the model.
Okay, disadvantage. The answer is at the bottom only. Second one is the answer. Second one is the answer. Okay. When we go according to the bag of words, it gives equal weightage to all the words. But we want that there should be a different weightage. Then there is a concept of PF IDF. Write it down. It is a term frequency and it is an inverse document frequency. So those words which are repeated quite often, their weightage is decreased, and those words which are less repeated, their weightage is increased. Okay, so it's basically inverse document frequency. Now, what are the common words which are always used in any of the records? Patient. So its weightage is to be decreased, but rare information such as myocardial, neoplasm, its importance has to be increased. So that's the reason we go for inverse document frequency, term frequency and inverse document frequency. Clear? Is it clear? Bag of words converts everything into binary, and on that basis we'll be building up the vectors, because now everything is binary, 1 and 0. After bag of words is being completed, we go for embeddings. In this, we are having 3 types. Please take the screenshot of this. Please take the screenshot of it. So, bag of words, TF-IDF, and co-occurrence matrices, it falls in frequency-based embeddings. Prediction-based word embeddings are word to vector, glow, fast text, and contextual word embeddings are transformers and GPTs, which we have started using. Very powerful than this frequency-based embeddings. Now, word embeddings. So it's a dense vector representation of words capturing semantic relationships. Okay, capturing the semantic relationship. Now, all of you just wait and I will start R to explain you what we are doing. I'll be sharing a screen with you. Just a minute. Is screen visible, all of you? Screen visible?
No, sir.
Yeah, is it visible now?
Yes, sir.
Okay. So this is a good package, UD pipe. I will activate its library, run. Then a model is being created. Just you have to write down this so that the UDP model gets activated. Then a model is being done. Now we will feed the text. Is R visible? All of you? Is R visible? No? Okay. The patient reported chest pain and was diagnosed with angina. There is a consolidation in the right lower lobe, consistent with the pneumonia. Mild cardiomyopathy is noted. So this text, I'll feed it. Then a model, the text model is being done. Now I'll convert it into the data frame. Now, can you tell me what I'm doing here? Entities are being created. What I'm doing here? What did I do here? Token, lemma. What did I do here? It was tokenization. After the tokenization was created, see this. Now I'll activate the library deployer igraph. I'll use it and I want to check the co-occurrence of the word. So directly library igraph, I'll bring this here, run, and on the right hand side, can you see the cause and effect relationship which it has developed? Is it visible? Is it visible? Hello, is it visible?
Yes, sir.
Yes, sir, visible. Yes, sir.
So there
Yes,
is,
sir.
this is what is a
Herein
relationship.
is visible.
This is a relationship extraction which we are able to do. Now imagine we are having so many records. Definitely I'll be able to come up with some type of records. Somebody had asked about the diabetics. So diabetes, you can develop this type of theoretical, this type of a model, that what is a stress, what is, then you can divide the data into the age group according to the gender, and you can give different output. Okay, shall I proceed further now? Now, sentiment analysis, I will show you later on that how we do the sentiment analysis also in R. So this is word embeddings. In this, we are having two. Word to vector developed by Google and Glow, Stanford in 2014. So instead of counting the words, we want a relationship between these words, and that's the reason we use this word to vector. We want to build a relationship between these words. So tokenization is over. Now in word to vector, we are having skip gram. You see just at the bottom, skip gram. And the next is continuous bag of words. So we want to predict what are the words which are being, what will be the next word which will be used. Basically, it is a prediction orientation. When you are writing on Gmail, it suggests that this can be the next word Google. So they are using word to vectors in this skipgram and continuous bag of words. It can also understand the gender relationship, that is king, queen. So gender relationship also it can understand. Global vectors were developed by Stanford in 2014. It was a further step, and it is a global co-occurrence of word. Now, what is the difference in this and this is it considers a lexicon. It also considers whatever available is on the internet, Wikipedia, and the global co-occurrence statistics. The global co-occurrence of the word is being considered in medical healthcare system. So word embedding is a universal set in which we are having two parts, word to vector and globe. So basically it is a vector representation of a words in continuous space. And here our objective is prediction, and here our objective is count-based model used the co-occurrence statistics. This is predictive, this is statistical. Google developed it, Stanford developed it. Training on the local context. This is training on the global word co-occurrences. Skipgram or Sibao. This captures co-occurrence probabilities in the words. Learns king, man. King is a man and a woman is a queen. Learns from how often ice and cold appear together. This is a static vectors, one vector per word regardless of sentences. Does not change based on sentence context. One vector per word. So bank, reverse versus finance is ambiguous. So bank for this particular thing is ambiguous. Same, cannot handle different meanings of the same word. This is a limitation. Now, we are having a sentence. The king and the queen live in a royal palace. Word to vector, what it will learn? Learns that the king and queen appear in the similar context, the royalty and palace. Glow captures that the king and palace co-occur with the words like palace. So here it's a context and here it is a co-occurrence. This is a difference between both this. Shall I proceed? Shall I proceed with this? Hello. Hello. Okay.
Yes, sir.
Now the practical applications of NLP. First is sentiment analysis, chatbots, information extraction, and machine translation. We have already seen that in case of NLP, there is a complexity in the terminology, ambiguity and synonyms are used, nested entities are used. Nested entities are used such as left ventricular hypertrophy. Now, this type of entities, those who are aware about SQL, it is very difficult to create such type of entities. Very difficult, very difficult. And there is a data scarcity, as well as the standardization is missing, as well as updation is missing. Now, what is a major reason why the records are not uploaded on government websites? Tell me. Why? Why don't nobody wants to upload the records? Is it good? It's good for us, but the records are not uploaded. Why so?
That due to the privacy concern.
Privacy is, I see there are, whenever I say data, it is a privacy. But apart from this, what is the thing that why they are not uploading the records? Our intentions are good, but why
Yes.
is it not happening?
That is also my concern. They don't share the data set also.
That's also your concern.
Yes, sir.
So what is your observation? Why they are not uploading it?
I don't know. I have contacted many hospitals also.
Ah,
I'm working on the Alzheimer disease.
right.
I need the good data set, but they don't share. They are just telling that it's our privacy. Then they don't want to share.
Okay. What I have found over this year is the first problem is of the operationalization. Operationalization in the sense that who will upload so many documents? Are we having enough manpower to do this? So they are ready to do, but we don't have the manpower. Already in medical sciences, they are struggling for the manpower, and this additional load, who will do it? One. Second, cost incur. Third, are we having sophisticated, robust machines to upload all these documents? Are we having a skilled people to upload this? Just check about this. They don't have it. And in the last 2 or 3 reasons which I found is that the hospital thinks that if we upload these documents, then possibly the government is intervening, the government is interfering, and we don't want all these things to happen. So these were the reasons which are identified, and because of which the health records are not upgraded quite frequently, right? Now let's
Hello, sir.
proceed. Huh.
Uh, Regarding this issue, what I observed,
Huh.
like even the patient is admitted, even our relative or ourselves is
Huh.
admitted in the hospital,
Huh.
even they don't share our data with our relative or ourselves itself.
Yes, 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 yes.
They record what the medication they have like done through the admittance of the person in the hospital
Hmm.
or during the tenure of admission.
Hmm.
Even they don't reveal that, they don't want to give it to what they don't want it to, out of the hospital.
Yes, yes.
So there are like many things are there happening.
Yes, there are
That
many
might
things.
that might be the reason.
But there will be, there will see, there will be a day when things will be good. This is our
Yes,
assumption. There will be day when things will be definitely good. And I have seen a country in which this is implemented, and this is
yes, I am.
working. This is working very nicely, and it is not
Yes,
a ear heard story. I had myself experienced the way they are working, and the chances of any errors is very, very less. Okay.
yes. In many countries, like data sets available,
Mm,
and they are like preserve the personal information, and they are sharing the rest of the of clinical observations, pathological observations,
mm, mm, mm,
or maybe surgery, what they have done. Everything is like available in multimodal records.
mm, mm,
But
mm.
India, it is like somewhat difficult. But as you said, like in coming years, it will be happening. So
It let's have a high hopes in this way, in this way. Okay.
yes, sir. Yes, sir.
Now the game changer was by Vashwani. The paper was written in 2017. It was just like a Transformer movie. And the name of the paper is Attention is All You Need. What was the title of the paper? Attention is All You Need. Right? With me? So basically, it is having a self-attention mechanism, enhanced parallelization, and revolutionized an NLP. Now, what are the difference between traditional models and transformers? Here, in case of traditional models, the processing was sequential. Okay. In case of transformers, it was parallel. Here, long range understanding was limited. Here, it was strong. Training time slow, fast and scalable. Here, domain adaptation was hard. Here, it was very, very easy. Right? Is it clear? Examples, traditional models are few. Transformers are BioBERT and clinical BERT. Somebody had rightly pointed out what are the transformers. So BERT, BioBERT is a very nice transformer. So here we in this case, what are the features of BERT? So here something is, yeah, here this self-attention mechanism is there and enhanced parallelization is there. One example I will give. There is a patient, the patient who had a history of diabetes and was recently diagnosed with COVID-19 presented with the chest pain. So the word chest pain might be related to COVID-19 or the pre-existing diabetes. Now there are overlapping symptoms, Two diseases are having overlapping symptoms. So these transformers are based in removing that overlapping systems. So the self-attention mechanism helps the model. This self-attention mechanism helps the model to weigh the relationship between the parts of the sentences, regardless how far they are apart. Okay, how far they are apart. In one paragraph, the disease was written in the first line and the symptoms was written in the third line. This self-attention mechanism, these transformers are so capable that it can establish a relationship between the first line and the third line. Very unique concept. It is an enhanced parallelization. So processing can be done parallel, not sequential, and therefore it saves a lot of time. One of the good transformer is a BERT. The name itself suggests bidirectional. It reads the text from left to right and right to left. And as it does on both the sides, it saves a lot of time. So that is BERT. Okay. It works from left to right and right to left. Now, in health sciences, we are having three BERT: BioBERT, clinical BERT, and blue BERT. So the key features, BERT, I already told you that it reads from left and right. Yeah, here is it. BioBERT, clinical BERT, and blue BERT. In case of BioBERT, the training data is PubMed PMC, clinical BERT Mimic, Bluebird PubMed and Mimic 3. What are the strengths? Biomedical literature, clinical abbreviations, shorthand, broad biomedical plus clinical scope. And here it is used in literature mining, discharge summaries, electronic health record analysis, entity recognition, and text classification. Is it clear? Is it clear? Any questions? Shall I proceed?
Yes, sir.
Now, let me take some features of BERT. So BERT is having a massive corpora like Wikipedia and book corpus, from where it runs. It allows fine tuning of the modeling. There is some concept which is known as a masking, masked language model. I have taken it or not, let me see. Masked language model. It can work on masked language model. Yeah, here is it, MLM. And next sentence prediction. What is this mask? So listen to my this sentence very carefully. The patient was given dash for pain. What is my sentence? The patient was given dash, filling the blank, for pain. Now this BERT is having a capacity that it can go in between. It's not a case of next sentence prediction or next word prediction. It can filling the blank in the sentence also, and it can suggest. So BERT will predict that the ibuprofen is best for this combination. The patient was given ibuprofen for the pain. Next sentence prediction, we all are aware about now what will be the next word, and as we are using in hello. Okay, next. The power of advanced NLP, with this we have done it. Okay. Fine tuning. It's basically a continuous training the pre-trained models on smaller task-specific labeled dataset. It's a continuous training. It achieves significantly higher accuracy on target domain, improving performance by 5 to 10%. Data requirement is very high, and use cases, specific disease, drug classes, or clinical notes. Now, leveraging the models. First is processes, techniques, benefits, and limitations. I was doing all this thing in R. Everything I was doing it on R. And suddenly one fine day, a prompt engineering was being launched. Prompt engineering. And in this, there is one word, zero shot, one shot, and few shot prompting. And it is working extremely well in ChatGPT. Don't think that prompt engineering is a very easy domain, or it's very easy to work on ChatGPT. No, it's ChatGPT is having three things. One is settings. Second is the framework, and the third is technique. If all these three are combined together, very soon I'm launching a program on prompt engineering for doctors, for health physicians. Hmm? How to use ChatGPT for the doctors? Because ChatGPT is a very general thing, but how can I make it customized for my clinic, for my hospital, that I will train you. So here prompting is, you will have to understand the prompting, the skills of the prompt engineering are necessary for this NLP. Strategic applications, fine tuning versus zero shot. Now, what is the difference between fine tuning and zero shot? One is a technique, another is a setting. Listen, this is technique. So, zero shot, one shot, few shot, chain of thoughts, tree of thoughts, retrieval augmented generation. Anybody aware about RAG? Anybody aware about retrieval augmented generation, RAG? It is specifically used in only medical sciences, RAG, retrieval augmented generation technique, and here fine tuning. Now in ChatGPT, we are having temperature. In ChatGPT, listen to me, we are having temperature. We have to do the setting of the temperature. In square bracket, I am writing a prompt here to make you understand that how we activate the temperature. Relationship between chest pain and heart attack, temperature is equal to 0. Enter. Just see this prompt in your chat box. Okay. Just see this in your. What do you mean by temperature? What's the meaning of temperature here? Anybody? Just tell me what is the meaning of temperature here?
Is it your body temperature?
No, that's a mistake.
Sorry.
See, ChatGPT has been designed in such a way that its temperature is at 0.5. Temperature, it's a ChatGPT temperature is at 0.5. It means that some facts it will take and something it will generate on its own. When you're working in medical sciences, you want that the ChatGPT does not generate anything on its own. It should only be working on the training data set or whatever things which are available, what are facts which are available. So as soon as I make my temperature 0, it will not start writing something from the haywire or something on its own. It will only write based on facts. I can increase this temperature to 1. So as soon as I make it temperature 1, this will now not stick to the training data set. It will start writing on its own. Now, why this difference is necessary? See, there are some domains in which temperature is equal to 1 is necessary. We want that the chat GPT writes something new. So we want to generate the new poem. We want to generate the fictional new plot for the movie. So here something new is necessary. But when I talk about medical sciences, pure sciences, I want that it should stick to the basic information which is available. So temperature is equal to 0. If you set it, it will not give you the problem of hallucinations, which is a basic problem in any large language models. And eventually NLP and large language models, they are going to converge. Most of the things we will be able to do through ChatGPT only. Is it?
Sir, is that fixed value or restricted value or garbage value?
Is it a, sorry?
Sir, is that means it's fixed value or restricted value?
No, I know this temperature.
Yeah.
It's not a fixed value. It's not a restricted value. It is known as a setting.
Okay.
So as soon as I make temperature is equal to 0, it will talk about facts. As soon as I make it 1, it will move beyond facts and it will start generating on its own. That's the only difference. And
Get it.
default setting is 0.5. If you want to see about this more about this settings, I will also share my YouTube channel with you, where I have discussed about the settings, techniques, and frameworks, how to handle ChatGPT, and I frequently organize these workshops. There is one more sorry, there is one more setting which is top P, top K, frequency penalty, and when you introduce all this in your prompt, it will become a very nice, or rather this, once this setting has been introduced, ChatGPT will not give you the wrong answers, which is a normal problem which we all face, right? Let's proceed further. Next is relationship extraction. In this, one of the branch which is coming from NLP is relationship extraction between the disease, symptoms, disease and genetics. So many entities relationship we want to develop: drug, disease, drug, symptom, drug, genes treatment, disease treatment, so many relationships. So here now I'm started talking about cause, effect, associations and treatments. So for instance, drug A treats drug disease B, so the treatment relationship. Problem is the overlapping symptoms, that is an ambiguity. Aspirin can be can do both, can both prevent and cause headaches. This is ambiguity. Again, the problem of negation, complexity, multiple entities in long sentences, and data scarcity. Somebody who had rightly said, we talk about rule-based system, then supervised learning, distance supervision, and deep learning, where we are using the convolution neural networks and recurrent neural networks, LSTM, transformers, we have started using it. Now, what is the rule-based system? What is the rule-based system? Anybody wants to share rule-based system?
Finding the previous patterns or the previous
Let's make it very simple. Okay, rule-based system, I'll make it very simple. If you have purchased if you have purchased tea, what is your probability that you will purchase sugar? Okay, now if you have purchased tea, sugar, what is your probability that you will purchase the next thing? So I am specifying some rules. If you are having X disease, what is the probability that this comorbidities will be present? Okay,
But it is basically
basically
association rules.
these are association rules which we are building up.
Yeah.
And normally it is built up with the help of the decision tree.
Yeah.
Okay, it is normally if you are using orange software, very nice software, it can build up the rules very nicely. This is also there, this video is also there, so it builds up the rules. But there is one problem in this: it is always moving from left to right. The context is one-sided. It is not learning from right to left, which is very much necessary in case of medical records. Next is supervised learning. So in supervised learning, large data set is there. We are clear that there is one dependent variable, one target variable has to be studied. And when we specify it, we are able to get the relationship that these are the factors which causes this type of this type of disease or this type of treatment is necessary. So here it is necessary that we specify the dependent variable. Next is distant supervision. Distant supervision is just giving a cheat sheet. Cheat sheet that if this is there, this is there. If this is there, this is there. A cheat sheet, just like a ready reckoner, which we give a ready reckoner or a guide, ready-made guide, that if these are the symptoms, then this is a possibility. If these are the symptoms, then this is a possibility. So this is a cheat sheet which is given, that is a distance supervision. Normally, for this we run nearest neighborhood, NNN. KNN is used to find out the distance supervision. And the last is the deep learning, in which the transformers are doing extremely well. Now let's proceed further. Applications in healthcare, drug to drug interaction. So identifying the potential health adverse effects, disease symptom association, linking symptoms to disease, treating outcome prediction, determining the effectiveness of treatments, providing evidence-based recommendations, detecting and preventing adverse drug reactions. So this is where this relationship it comes into the picture. Okay. Next, the next part of NLP is sentiment analysis. Why is it necessary? Sentiment analysis. These days we talk about sentiment analysis. Why is it necessary? It was not there previously. Why sentiment analysis is necessary? How is it captured? Why is it necessary?
More for customer feedback, which is usually a textual thing. So understanding what they actually mean with lots of e-learning platforms.
Yeah, this is right. But nowadays, or rather, people are using social media and people are putting the things on Twitter, Facebook, and we have to figure it out that what has gone wrong, where we have gone wrong, why the things have gone wrong. So there are some softwares. I also teach the qualitative data analysis using NVivo. In this, we are having that we can link the Twitter in NVivo, and we can do the sentiment analysis about our product. I'm also having one website. Just a minute, I'll share with you. Just a minute.
Excuse me, sir.
Yeah.
Yeah, can I give one example where the sentiment analysis is used?
I'm
It would
coming
be
to it.
helpful.
I'm
Okay.
coming to it. I'm
Okay.
coming to it, right? I'll show you one website which will do the analysis of 100 tweets very easily. Just a minute. Just a minute. If I'm getting it or not, let me check.
Hello, Vasudha madam. Aishwan, hello.
Yeah.
Vasudha madam, hello.
I'm sharing again a screen with you. Very nice website. See this. Note down this website. It is CSC2, or I'll send the link only. Just check in your chat box. Did you got this link? Check. So it is basically visualizing the twitch, representing the emotions, estimating the sentiment, right? Visualizing technique. Sentiment tabs are there. Topics tabs are there. Okay. And narratives are there. This website. And you will be able, and here is it. Just see. Can you see this? Try the visualizer online. Hello. Can you
Yes,
see
sir.
this? This one. Just click on it and connect your tweet here, and it will give so many outputs. See, so much output it can give. It's very interesting thing. Okay. Everything it will give it to you. Right? I will also copy it so that I can keep it with me. Okay. Again, sharing the screen with you. Now, why sentiment analysis is necessary? Because the feedbacks are to be analyzed, which are feedbacks which are given on text format on Twitter, and we have to analyze it so that we can improve our services. The value proposition is why we want to do it. So it gives me the real-time insights about the satisfaction levels of our patients. Proactive identification, where we want to improve. Enhanced decision making. Next is the competitive advantage. The patient experience scores are to be recorded. So we can analyze the patient reviews. So somebody had wrote long waiting times consistently flagged as a negative in 30% of the reviews, and definitely we can improve upon that part. On feedback on services can be analyzed. Doctor patient communication can be analyzed. For emotional cues in transcribed conversations, identifying the barriers, potential misunderstandings which might have happened, and support training program. Okay. Now, there are some ethical considerations about data privacy. We have to be compliant with the GDPR regulations is crucial. Algorithm fairness is necessary. Very crucial thing has emerged in health. Okay. What is about this biasness? All these transformers, all these neural networks, or all these large language models suffers from biasness. What is this biasness, and why this biasness has been introduced? Why there is a biasness?
Output varies from the actual.
No, the variation in the output is it's fine. This is not related to output, and the variation is bound to happen. I'm not talking about output variation.
Okay.
I'm not talking about output variation. I'm talking about something else. Okay, you can see on the Google. This NLP was implemented in some hospitals, and the priority of the patients belonging to a particular race. I'll use the word race. Let's be very political correct. Were given more priority. I'm talking about US only. Were given more priority in comparison to the another race, and therefore this is a bias. It has been found that when these models were implemented in recruitment, a specific gender was given more priority in comparison to another gender, or rather the favoritism was there. Now, this is not the problem of the model or the machine learning. Basically, it gets a training from whatever is available on the net or website, or what we say, which is available on Glove, and from there they are taking the training. So if the training records are less for particular race or a gender, definitely the output is going to be biased, and we have to avoid the bias. The last is patient anonymity. This has to be maintained in all this, right? Is it clear? Conclusion is very good. Actionable insights can be achieved. Proactive approach, data-driven decisions can be taken, and strong relationships can be built. Now on R, I will show you something, how sentiment analysis is being done. Same data, I'll be using the package SUSET library text data. This is the feedback. I hope all of you are able to see R. Hello.
Yes, sir.
Now see this. Feedback is the staff was courteous, but the waiting time was too long. Doctor explained everything clearly and made me feel comfortable. I had to wait for hours and no one answered my questions. Amazing facility and professional service. The nurse was rude and dismissive. I want to do the sentiment analysis. Done. Sentiment scores are being generated. Done. Right? Sentiment labels have been given. Done. Sentiment results are being generated. Right? Now, I will activate the library ggplot2. Done. ggplot on right hand side. Everything which was in text now has been converted in our feedback. Is it good? Where we have to improve, where we are doing extremely well, it is in front of you, right? Entire thing was in text, analyzed it, and we got the results. Is it clear?
Yes.
So you please write down the library. Its name is SUSNet. Sorry. Okay. Now just wait for a minute. Is my screen visible? Kindly confirm.
Not yet, sir.
Facts. Okay, sharing the screen again with you. So this is my YouTube channel. The name is correct, Tawal Mehta, right? You go in the playlist and whatever you want to run, whichever software you want to run. So I have started uploading on Stata. large language models, structural equation modeling using Jamovi, SPSS, Orange 101 videos, MaxQDA, qualitative data analysis, then quantitative data analysis using atlas.ti, R, prompt engineering. This is what I was telling you. See the videos of prompt engineering, it will explain you. Alteryx, MS Excel, Power BI, AI tools for researchers, Tableau, Nine, Amos, Jamovi, okay, machine learning using Python, R Studio, time series, rapid miner, everything I have explained it. There is some concept of Dhaval Mehta groups. So there are total 13 DM groups in which faculties from all over the world have joined. I am sending the link of this in the chat box. Just click on it. You'll be able to join my group in which you will get the notification of all my workshops which are organized all over the world. Right? You will be able to join. Are you able to join? Just check. I'm also dropping my contact details here with all of you and the link of my YouTube channel. Just a minute. I'm also dropping my link of my YouTube channel. Just a minute. Okay, so this is the link of all my. So thank you all of you. I'll start the video. Any questions are there, please ask. I hope you enjoyed the session. Any specific questions are there, please ask.
Hello? Anybody have any question? Any query?
My YouTube link, I have shared it.
I have the
Yes,
same
yes,
question.
yes.
I contacted the hospital. Why don't they save the data? I have contacted the AIMS Rajkot also, video. They don't save. Why?
What should I say? We are on the social platform.
Okay.
And what should I say that what type of treatment we are carrying out? Are we transparent in this matter? Are we inflating the bill? Yes or no? Our bills are being inflated, right? So that's the reason. What should I say?
Yeah.
Right? We will not be sharing it. Okay. Any other question? If you are having, please tell me. Any other question? Yeah, I'm sharing the link with you, so you can join me. Yes, over to you, Dhanraj sir, and over to you, ma'am.
Thank you, sir, for such a great session, informative session. I would like to request Professor Bhakti Sahu ma'am to deliver the vote of thanks. All participants are requested to please switch on their camera so that we can take the screenshot.
Just a minute. Okay. Anything? Anything is left out? Any questions are there? Please ask.
If any questions are there from the participants, please ask. Okay. So good afternoon, everyone. On the behalf of this computer department, Dr. D.Y. Patil Institute of Technology, Pimpri, Pune, it is my proud privilege to propose the vote of thanks for the today's enlightening sessions. First and foremost, I extend my heartfelt gratitude to our distinguished speaker, Dr. Dhaval Mehta, sir, for taking the time to join us and share your invaluable insights on the NLP in the healthcare. Your deep expertise and engaging presentations on how the NLP transformative impacts on healthcare, text preprocessing, different token names, sentimental analysis. These are the topic you have covered in this session. So have truly inspired and enriched our faculties and the participants alike. So the way you connected theory with the real world applications was both informative and thoughtful provoking. Even in fact, you have shares your the YouTube channels and WhatsApp also. So we are very grateful for this. So we are truly fortunate to have you with us today. So thank you for adding immense value of our academic ecosystems. I also takes this opportunity to thank our management, Honorable Secretary Dr. Somnath Patil sir, our respected Dr. Dheeraj Agarwal sir, Director, Central Corporate Relations, Dr. Nitin Shetje sir, Principal, and our Head of Department, Dr. Vinod Kembone sir, for their continuous supports and encouragements in organizing such impactful events. And a special thanks to all our faculty members and organizing committee whose efforts behind the scene made today's sessions a smooth success. Lastly, I extend our sincere appreciations to our distinguished participants for their active participants and engagements to learn. Your curiosity is what keeps such events meaningful. So let us take this inspirations from today's talks and apply in our academic and professional pursuits with the renewal zeals. So once again, thank you all and thank you, Dr. Mehta sir, for being us today. Have a great day ahead.
Thank you. Thank you for inviting me. Thank you. Thank you, Vasudha ma'am. Thank you,
Thank you.
Dhanrasan, for inviting me. Thank you. Thank you.
Thank you, sir.
Attendance link and feedback link is shared. All participants
Thank
can
you very much, Dhaval sir.
Are you there, sir?
Hello, Dhaval sir.
Yes, sir.
Thank you very much.
Thank you, thank you, thank you, sir. अच्छा यहाँ पे okay, okay. Thank you, thank you.
Sir, and for next session, we'll be happy to have you, the participant can interview with you. I know there are like many areas you work on, so definitely we'll try to touch those areas, and your expertise will definitely help to grow our faculty in research. So once again, I'm thank you very much to you. Yes, sir. Now, please share the link with the participants.
Yes, sir. Already shared.
Okay.
Okay, we declare the session is over.